Hello everyone. In this video, we are going to discuss about rectifier. So normally, what is meant by rectifier? So a rectifier is nothing but which converts a AC quantity into a DC quantity. So that is thing called rectifier, the device which converts AC quantity to a DC quantity. So where we are using a rectifier? So normally a supply, right? The supply from the utility we get is AC. So many appliances or applications we need DC supply, and we can take a battery to store electricity. Normally, the batteries uh, are of DC. We can only store DC quantity. So we need DC. We need to convert the AC to a DC quantity. So for that purpose and all, we are using rectifier, and we can one of the major application is a mobile charger or laptop charger, right? If the supply we are getting is from utility or from the socket which are connected to a home, and our phone battery or laptop battery has a quantity to store a DC, right? And we need to convert the AC to a DC, so that our rectifier is okay. So, and what is full wave rectifier? We have half wave rectifier and we'll have full wave rectifier. The half wave rectifier is nothing but it converts both positive cycle and negative cycle. How it is, can just go through it. And normally for AC waveform is sinusoidal waveform. Okay, normally the AC waveform is sinusoidal waveform, and the DC is of straight line. Okay, the waveform of DC is straight line, but here in full wave rectifier we'll get a pulsating DC. Okay, we'll not get pure DC, we'll get the pulsating DC. So a full wave rectifier is an electronic circuit that converts entire cycle of alternating current into a pulsating direct current, not converted into a pure DC. For pure, in order to get the pure DC, we will be connecting a filters. Okay, and in half wave rectifier, it will convert only the half cycle. That is only either positive cycle or negative cycle. So we'll just go through the circuit. We can connect the full wave rectifier in two types of circuit. One is center using center tap transformer, and next one is bridge rectifier. Okay. So here we need a transformer. First thing, we need a transformer in order to reduce the supply which we are getting from the supply. Can we are getting 230 volt. So the 230 volt we'll be reducing it, and we are connecting it to two diodes. Okay. So here we have two diodes, and we are interconnecting it two diodes, and we are connecting it to a load. So normally you can just refer this. This is your input. You can take this as an input. Positive cycle, negative cycle. Okay. So during positive cycle, and this will be a negative. So in positive cycle, which diode is forward bias? We need to know the forward bias happen. I mean, the diode conducts only when the forward bias is happening in the circuit. So which diode is forward bias? Here the positive is connected to the anode. So this is forward bias. So in positive cycle, diode D1 is forward bias and diode D2 is reverse bias. So it does not conduct. That is, the diode does not works. And in reverse bias, that is when this is negative and this is positive, this is reverse bias and this is forward bias. So in negative cycle, D2 is forward bias. So D2 will be conducting. So what happens? So we'll get waveform. That is for both cycles we'll be getting the output. But in half wave rectifier we'll have only one diode will be present there. So the diode only will work for positive bias. I mean forward bias. So there will be one positive cycle waveform. There will not be negative cycle. And here we are getting, since we are connecting two diodes, this is for diode D1 and diode D2. So it works like this. And if you need to filter, you can just connect a capacitor here. You can just connect the capacitor. It just filters the waveform. You'll get somewhat nearby DC waveforms. Okay. And next comes the bridge rectifier. So bridge rectifier is will be connecting in form of bridge, and we'll have four diodes present inside: D1, D2, D3, D4. the working will be similar. We'll have two waveforms, positive, we have a waveform, positive cycle and negative cycle. Positive cycle, the forward bias, there will be two diodes working here. And in reverse in negative cycle, there will be two diodes working here. It will be similar. Okay. What will be the efficiency of, what are the advantages here is it has higher efficiency when compared to the half wave rectifier. And the ripple content will be very less here, and the output also will get a better output when compared to the half wave rectifier. The one of the major disadvantages, complex. Since we are in bridge rectifier, for example, you can take bridge rectifier. It has four diodes. The complexity will be very high, and the cost will also get increased. So that's all with this full wave rectifier. Thank you.